Okay, welcome to all my dear students. So today we are going to discuss about the dissolution apparatus, its importance and its operation manual and the standard operating procedures. So as you all know, dissolution is a very important parameter when compared to when coming to solid dosage forms, especially like tablets, capsules and powder dosage forms. Dissolution is a process of movement of drug from a tablet dosage form into the bulk of the solution. So this particular process phenomenon is going to influence the rate of absorption. Therefore, the prior to rate of absorption, rate of dissolution is highly essential. So USP considers dissolution as a very important process for establishing the quality of tablet or capsule dosage forms. So as we all know, USP, United States Pharmacopoeia or Indian Pharmacopoeia, any pharmacopoeia has a regulatory requirements, and being a very good quality control parameter, the instruments that are employed for assessing this quality is actually also regulated by USP or IP. So based on that, we have an instrument here which is called as dissolution apparatus, and whenever you are going to learn about how to operate an instrument, it is very essential to know who is the make of the instrument or manufacturer of the instrument. So as you can see, this is a Lab India Disso 2000 model. So in Lab India we have various models. So this is a Lab India Disso 2000 model, and as you can see, it's the digital tablet dissolution test apparatus. Okay, so if you now let us just see what are the visible components in dissolution apparatus. So once we come to know each and every visible component, then we can clearly understand the function of each component, then we can understand the process. Okay, so coming to the visible components, so the upper part which you are seeing is a movable hood, okay, which is used by a hydraulic pump, which is used for lifting the hood up and down. So this is very important, the movement, and it is very important in maintaining sufficient height of the paddle or basket from the bottom of the tablet. We will be discussing what is the importance of this height in later. So this is called as a hood, and this is called as a bathtub. So the tub holds required amount of water. As we all know, we are going to compare this in vitro dissolution in correlation with the human drug release in stomach. So we are going to maintain the same temperature as the temperature inside the stomach. So the human body temperature is about 37 degrees Celsius. So to maintain the temperature precisely, we are obviously going to use a heating bath. Okay, so this heating bath is holding different baskets here. So as you can see, there are different type of baskets. So as you can see, there are total of 1, 2, 3, 4, 5, 6, 7, 8 baskets, and in these 8 baskets, here we have got 6 baskets for the study and the 2 baskets for the purpose of replacing a fresh solvent or replacing buffer medium. As you are aware of sink condition, to maintain that sink condition, we are going to use these 2 baskets. And now as you can see, this is called as a 1000 ml beaker. So this particular basket is having a capacity of 1000 ml, and we can take approximately between 500 to 1000 ml of dissolution medium, which is actually similar to that of the gastric contents. Now as we all know, for dissolution to occur, we need a surrounding solvent system. So for that, we are going to select suitable solvent in which we are going to put the tablet dosage. And as we are discussing about the number of baskets, so generally though there are 8 baskets here, each having 1 liter capacity. So this is generally, there are instruments which are also named as 8000, Disso 8000, indicating 8000 ml. Now the 2000 doesn't indicate any ml here, and in this 8 beakers, we are having only 6 beakers which are using for testing. So these 2 beakers are only for replacement. So this instrument is generally referred to be a 6+2 dissolution apparatus. Okay, so this is the component here, and if you come to this part, which is a very functional key part, where we used to control each and every parameter of the dissolution study. A dissolution parameter is nothing but a variable that we encounter which will influence the change in rate of drug dissolution. So this is called as This is called as a central processing unit from which we can control the whole instrument. Now moving to here, so we have got one more component here, prismatic automatic sampling pump, and this is a peristaltic pump actually, and this is having a minimum number of variable panels. So if you see here the panel board, you have got pump mode and remote mode. So the remote mode says that now this pump is under the control of the CPU and you cannot directly operate or start or stop this instrument directly. Now as you can see this plug, when I remove this plug, you can see the change of this particular light from remote to pump mode, indicating that now the pump can be operated directly from this particular panel. So when I am placing back that, it is again changing to remote mode. So here the remote mode indicates that it is under the control of CPU. Now as you can see, from this we are coming to this particular component which is also visible for you, and as you can see this is called as Lab India sample collector. So the purpose of this collector is it will withdraw the samples into the containers into which you have to into which you want to collect the samples. Okay, so this is going to collect the samples, and as you can see we have got 6 baskets, we have got 6 samplers to collect the samples. Now coming from the samples here, from the container, the samples are collected by the automatic sampler using the tubing system. So as you can see we have got 3 sets of tubes, and each set is having 6 individual tubes again, each set. So each tube indicates one basket, and if you can see the 3 sets indicates that one set of tube which is connected here, particularly this particular 1, 2, 3, 4, 5, 6 is generally for sucking the sample, and after sucking the sample the pipes will be filled with the solvent system and it might have a trace amounts of drug. So again we have to wash the whole column of these pipes using these buffers that we have placed in 7, 8 end baskets. So these 2 pumps are one for inflow and one for outflow of the sampling system. So whenever you take a sample from the automatic sampler, it is going to rinse the whole tubules every time, assuring that there is no cumulative concentration accumulated with each sample when coming to the last sample. So this is the basic information about the components of Lab India Disso 2000 apparatus with auto sampler. Now coming back to the operation manuals and basic theory of dissolution. So as we said, whenever you want to perform a dissolution study, obviously what we are going to do is we are going to input a program. So what is a program input? A program input is nothing but the number of variables, that are involved in your dissolution study. So depending on the requirement of your tablet, you have different requirements like different RPMs, different temperature conditions. It might be different temperature conditions, or it might be different buffer volumes, or different sampling intervals. So all these variables you have to predefine to the system so that the system will automatically do whatever you are ordering it to do or whatever you are intending to do. Okay, therefore we are going to input the parameters into the CPU system. Okay, so let us just see how these CPU parameter inputs can be given into this and how we can add or delete or modify a program. Now as you can see, there is a simple display manual which displays various functions upon this. So as you can see, we have a simple key system. So as you can see, there is a reset button. If there is any malfunction during operation, you can press reset, but preferentially just make sure that you are pressing it very less time unless it is definitely needed. Now when you go for back button, just to go back to any when you enter any function, and escape button to come out of any activity that you are doing, and enter button to fix any program parameter, and hold button to run the system after writing the program. And the particular scan button is exclusively for the UV visible spectrophotometer, which can also be directly connected to the system, but currently it is not connected, so we are not going to use the P scan, that is program scanner. And you can see the up and down arrow button, as we discussed, it is to lift or move it down the hood. These are the controls and these are the normal number panels. Now coming to the LCD display screen, we have got various functions like program, run, print, function, data evaluation, and as you can see, there are certain parameters that is displayed, like bath temperature. It is showing like 33.9 degrees Celsius. It displays the time, and it displays the position of the hood. Now it says the position of the hood is in up position. It says 3 variables: up, down, medium. Okay, now as you can see, the USB, in USB we have total 7 different type of apparatus: USB 1, USB 2, USB 3, and up to USB 7. But currently we are having only, generally most widely we use USB 1 and USB 2 as a standard methods for evaluation for tablet dosage forms. Now as you can see here, this particular apparatus that we have is USB type 2 apparatus or IP type 1 apparatus. It's called paddle apparatus. And the one more type of apparatus that we have is basket type of apparatus. And as you can see only 1, 2, 3, 4, 5 and 6 baskets, and there is no 6 paddles, and there is no paddle here because we don't need to have any testing in these 2 baskets. There is only buffer medium for replacement or for maintaining a sink condition. Now coming back to the display inputs. So let's come back to the display inputs. So let us see how we have to give a program variables or program functions, and how we can write a program. So as you can, the operation is very simple. Select the number that the program is assigned. So if you want to select program, press 1, and if you want to run any program, press 2, and vice versa, 3 and 4 depending on the requirement. So now I am just going to show you how to input a program. So now what I have to press? So I am going to press number 1. Now it says programs. Now you are inside the program function. Now in the program function we have 4 different options, like do you want to add a program, you want to refer or view a program, you want to copy the program to another number, or you want to delete a program. So as we are going to add a program, now let us add a program into number 1, and this instrument, let us see what will happen when I press 1. So I am pressing enter. So it is asking for a password, so required password by the analyzer. So once you enter into the program, as you can see, the program display says you can add programs ranging from 1 to 15. So the maximum number of programs that we are going to add is only 15, not more than that. So it is asking whether you want to add the program or you want to edit the program. So we are going to add the program. Now it is asking for a sample name that you are going to go for. So the sample name is going to be obviously the type of drug you are going for testing. So for example, if you are going for curcumin, so obviously we are going to go for a sample name. So it is going to be C, U and C. So curcumin. So press enter, and it says you want USB apparatus 1 or USB apparatus 2. As I have just discussed, USB apparatus 2 is paddle, and it's already paddle is attached. So we are going to select USB apparatus 2 and press enter. Now you can see the steroid depth. The steroid depth is defined by 2 variables, that is, one is 25 mm and the other one is 40 mm. So I just need to give a little more clarification about the depth and mm. So coming back to here, you can come close. So if you take a beaker or a basket, you have 3 baskets here, and you have 3 dosage forms, same tablets, and you have got same volume of dissolution medium. But let us illustrate that the height of the paddle from the tablet is going to vary. Now as you can see, as the tablet height varies, we can expect a variable rate of drug dissolution. As tablet height varies, we can observe variable rate of drug dissolution, because as you all are aware of surface renewal theory, in surface renewal theory, more frequent the surface is renewed by a fresh solvent, more is the dissolution rate. So when you have paddle close to the tablet, obviously the renewation is going to be much frequent, and so therefore there might be more drug release. So considering this depth parameter, considering this variable, USB has defined a fixed value for the variables. So if you are using a paddle system, the variability and the depth that you have to maintain is only 25 mm plus or minus 2.5 mm, or you can even write this in centimeters. So it can be 22.5 centimeters plus or minus 0.25 centimeters. If you are using a basket apparatus, obviously, as you can see, the basket do not have any type of paddling or impeller system. It cannot cause much turbulence. So to get the required turbulence as that of a paddle, we are going to come little closer to the tablet. So we are going to reduce the depth here, and it is going to be 20 mm plus or minus 2.0 mm, or 2 centimeters plus or minus 0.2 centimeters. So as we all aware of, the rate of dissolution can be influenced by depth. So obviously we are fixing the depth to 25 mm. Now generally, when will you use 40 mm? Because in USP it is not specified for the basket, nor it is even specified for the paddle type. So how come an instrument manufacturer gives you an option to select 40 mm depth? So there is a technical reason behind this, which most of the students are not aware of. So when you have a 40 mm depth, there is a technical reason. Now let me explain you with the small illustrations here. So when you have a paddle and when you have a tablet, when a paddle, especially I'm talking about paddle system, so when a paddle is rotating, it is going to swivel the liquid in these directions. So the liquid is going to go in either in this direction. So it is going to in this way. So because of this flow, whenever a paddle is rotating at lower RPMs, it is going to form a stagnant layer just below the paddle. The liquid that is just below the paddle is stagnant. It is not moving as equally as that of the solvents that are surrounded by the paddle. And obviously, as you all know, the tablet is actually placed just below the area. So this volume is generally considered as dead volume. Dead volume in the basket. So a dead volume in the basket is generally observed only with the paddle type of apparatus, and it is just below the paddle. When you have a dead volume, actually what is going to happen, as you all aware of, the rate of dissolution is going to get decreased. So you are not going to interpret the drug release from the tablet equal of drug release in vivo. So in vitro evaluation is, you are going to interpret wrongly because of unawareness of these dead volumes. So by most of the researchers have studied the occurrence of these dead volumes. So to avoid this, there is a solution provided by a company called, and that type of vessels are called as peak vessels. They are called as peak vessels. So these peak vessels are going to actually reduce the coning effect or dead volume. So this particular formation of cone is also called as coning effect. So it is this, having this USP peak vessel, it is going to reduce the coning effect. Due to presence of this peak, it is going to have more height. So you have to select 40 mm depth when you are using a peak vessel, but not generally with official. Now 40 mm height is not at all suggested by USP. So as what we have discussed here, USP peak vessel, USP peak is not an official apparatus, but it is a trademark which is used by formulation R&D people just to know whether there is coning effect during dissolution study or not. And as I also said, the coning effect is not common in all type of solvents. It varies with the type of composition of buffers that we are adding to the solvent system. So a little increase in viscosity can add more coning effect. So you have to check whether there is coning or not. So to check whether there is coning or not, what you can do is you can use a tilt paddle technique. So in a tilt paddle technique, we are going to tilt the angle of the paddle from 90 degrees. So this is a 90-degree paddle. We are going to tilt this angle to 45 degrees. Thereby we are removing the dead volume space here. So you can use 45 degrees on either the direction, and you can check the dissolution in this way. and you compare the dissolution of this tilt paddle with a straight paddle, and if the drug release in tilt paddle is much higher when compared to the straight paddle, it indicates that there is a coning effect. And these type of studies are referred as perturbation studies. So they are referred as perturbation studies. So perturbation studies are generally employed in dissolution just to understand whether there is coning effect. Thereby avoiding the coning effect, we are going to interpret the in vitro drug release exactly correlated with that of the in vivo release. Now I think you have understood why we are going to use a 40 mm depth. So 40 mm depth is only used when we are going to use a USP peak vessel, just to understand the effects of coning. Okay, so now we don't have any USP peak vessel here, so I am going to go for USP the steroid depth at 1. Now it's asking for buffer volume. As we have discussed, the volume can vary from 500 to 1000 ml in a closed basket system, and the most commonly used volume is 900 ml. And you can ask me a question whether 900 is a fixed volume. No. 900 ml is not at all a fixed volume. You can take any volume ranging from 500 to 900 ml, and generally if your drug belongs to type 2 of BCS classification with low aqueous solubility, you prefer to have more buffer volume, because as we know Le-Chatelier's principle, as the solvent concentration increases, rate of dissolution will increase. As solvent concentration decreases, rate of dissolution will decrease. So considering the Le-Chatelier's principle, you can take volume up to 1000 ml, but do not exceed more than 1000 ml, because that's the maximum volume of your stomach can hold, a liquid that your stomach can hold. So for type 1, so for example, if you're going for a drug dissolution which belongs to a type 1 of BCS classification, obviously you can go for 500 ml of buffer solution. 500 ml of buffer solution. There is no necessity to go for 900 ml when the drug dissolves happily in a very low solvent volume. Okay, so next we have entered 900 ml, and as we are going to go for curcumin drug, so curcumin is a poorly soluble one, so obviously we are going to go for 900 ml. Now you can see the bowel temperature. So the bowel temperature is going to be between 30 to 40 is maximums that you can enter. Why we have 40 degrees Celsius range is when you have a type 5 apparatus, where you are going to go for dissolution of transdermal patches, the temperature condition you have to maintain is only 32 degrees Celsius, because it is the skin temperature, our external temperature, not inside body temperature. Now whenever you are going to go for temperature equivalent to animal absorption studies like rabbit or rat, the temperature is going to be 39.8 degrees Celsius. So to facilitate that dissolution studies in various type of animal models, also to in vitro comparison with animal models also, we have got this much temperature range. So the temperature input here is obviously it's going to be our human body temperature, and it is 37 degrees Celsius. Now as you can see, the bowl is this one and the bath is this. So the bath temperature is going to be just a little higher than the bowl temperature, and it is going to be 37.5 degrees Celsius. And you can see the RPM. So the RPM can be 20 to 200, and in some apparatus it can be between 25 to 250. Okay, so generally is it necessary that we have to have fixed RPM, or is it necessary that the RPM must be only 50, 75, 100? Yes. As we all know, the amount of turbulence that we create will influence the rate of solvent renuation. So the rate of RPM, the revolutions per minute has to be fixed. And generally for research purpose, we can have RPMs ranging from 25 to 250. Now it can be 25, 50, 100, or it can be 75. The most commonly studied RPMs are 25, 50, 75 and 100. And as per USP or IP, the official specifications are, if you are using a paddle, go for 50 RPM because it can create a good turbulence with 50. If you are using a basket method, go for 100 RPM, as in basket, as we have discussed, there is no impeller to create the turbulence. So the created turbulence will cause to change the flow from transient flow to turbulent flow, as it is said in Reynolds number. So here when we are going to use the maximum RPM. So generally in industry during formulation developments, we are going to use the maximum RPMs, that is 200 or 250, which is called as a recovery test. So recovery test, what is a recovery test? A recovery test is actually a test which is used to identify the maximum efficiency of any particular dosage form to release the drug. Suppose if I take a tablet such as curcumin and I have studied the dissolution for 1 hour and at 250 rpm, and the maximum amount of drug released at 250 rpm is going to be 600 mg out of 1000 mg. That means it can perform up to 60% only. Obviously at 200 rpm we have 60% release. You are not going to get this release at 50 rpm. That means the maximum performance this tablet can give is only 60%. Now during the dissolution study, at any point of time your release is more than 60% than that of the recovery study. That indicates that there might be some error, or there might be some error in the formulation. It should not be more than 60. So generally all dosage forms will have 100% efficiency during recovery tests. So recovery tests are not regularly used by academicians, but they are definitely used during formulation studies. Okay. Now coming back, so here we have a paddle system and we can have 50 rpm. And one more thing, when you are selecting for 50 rpm, suppose I have selected a 50 rpm, but when I use this tilt paddle technique and observe that there is a coning effect, to avoid coning, either you can use a peak vessel or you can also use an increased rpm. So at what conditions we can increase RPM? If there is coning effect, we can definitely increase the RPM from 50 to 75. It is officially described by the United States Pharmacopoeia and Food and Drug Corporation, FDA. Now, so we have entered 50 here. Now let's go for sampling mode. So the sampling mode is this program is what we are writing for the sampler. So there are two types of programs in sampling. One is auto mode and the other one is manual mode. So in auto mode, the sample, you just fix the time, you just fix the number of intervals, and automatically it will take the samples. For example, if you have in auto sampling mode, if you have 10 samples and you want one sample at every hour, obviously the number of samples are going to be 10 and it is going to collect this automatically. But in manual mode, the individual has to manually take the samples by the use of the pump. So he has to manually switch on the pump and switch off the pump. Under such conditions, under manual conditions, you have to dismantle the system from remote mode to pump mode. Okay, just convert the system from remote mode to pump mode. So now we are going to go for auto mode. So let me press enter. So in auto mode, it is asking the next variable that we have to enter is the sampling volume. So what's the sampling volume that we want? So generally the sampling volume can be between 0.5 to 25 ml as described the instrument. But as we all know, less the solvent volume we collect, less can be its accuracy. So generally for repetition studies, for having good precision and accuracy, we need to collect a sample volume not less than 10 ml. So obviously we are going to go for either 2.5 ml, 5 ml or 10 ml. So here we have entered 10 ml. And the next thing is it is asking whether you want samplings for fixed or samplings for programmed. So so let me give a small explanation about this. So sample for fixed is, as I discussed earlier, a fixed sampling is like if you want 10 samples and one sample for each hour, the total number of samples are going to be 10 and it is going to perform this test for 10 hours, right? Whereas, so it is going to be simply 1, 2, 3, 4 and so on up to 10. Whereas in programmed, if your drug is a rapidly releasing drug, if your drug release is much faster and you want samples even at 5 minutes, 10 minutes, 15 minutes initially, later you want the release for 1 hour, 2 hour, 3 hour, you have to go for the program mode. So whereas in program mode, maybe the total number of samples are 10, but you have to program like you want a first sample at 5 minutes, second sample at 10 minutes, third sample at 15 minutes, fourth sample at 30 minutes, fifth sample at 45 minutes, and from then you have a sample at 1 hour, 2 hours, 3 hours, 4 hours and 5 hours. So 1, 2, 3, 4, 5 and 5, 10 samples. So you can program the sample depending on the individual requirement. So we are going to go for programmed sampling. So press enter. So once the bath gets completely heated to the required set temperature, so we can press the hold button, and it will say the SC is initializing, and it is asking you to wait. That SC indicates that sampling collector, so SC for sampling collector initializing, so it is transferring the program data to the sampling collector. And when it says run, the window says run, so you can press hold button and you can see the starting of all the things. So we can have RPM 50, first interval, and the first sampling time is 5 minutes, and the time till now is 11 seconds. So you can see the apparatus running, and once the time completes to 5 minutes, we can see the sampler moving back and forth for collection of samples. So let us wait for 5 minutes and you can see that. Number of samples, so we can enter the manual program and we can enter even each and every sample number. So here we have to enter the programmed sampling, so 0, 0, 0, 0, 5 minutes, 15 minutes, so 15, 30, 45, 1 hour, so 60 minutes. We cannot enter 60 minutes directly, so 1 hour, 2 hours, 3 hours, 4 hours, 5 hours and 6 hours. So when we have completed total 10 number of samples, so the instrument will display the total process time, so it's about 6 hours. And as you can see, there is also a wavelength option, so it is between 190 to 1100 nanometer. So we can connect this instrument directly to the UV visible spectrophotometer, but obviously we don't have any UV visible spectrometer connected to this, so we are not going to enter any nanometer there. And with this we complete the programming. Now if you want to view the program, you can view the program, or simply once you finish the program, press the escape button, which will take you to the main display page. Now once you want to run the program, just press 2 for running the program, press enter. Now the number of program that we have entered is 1, so press 1 and enter. So you want to run the program or view the program, so we are confident what we have written, so we are going directly for running the program. So once we run the program, as we have given a identification characters, so this will ensure that whatever the program we are going for is the same what we are going to do. So obviously the characters we have given for curcumin is obviously C, U, so just going back, so it's going to be C, U, C for curcumin. Press enter. So once you press enter, you can see it is displaying some parameters like bowl, RPM and bath temperatures, and it displays the bath is in heating. So we can switch off the heater and we can see the paddles started rotating depending on the program that we have input. Once the bath is complete, heating is complete, it displays to run the program. So we can add the dosage form and collect the samples directly by the auto sampler, and we can take the samples for further analysis by using UV visible spectrophotometer. So now the time is coming close to 4 minutes. So the sample is slowly getting ready for the sampling, and as you can see, the sampling collector has come down for collection of the sample. As the time reaches 5 minutes, we can expect sufficient amount of sample in the basket. So we have added the tablet for basket number 4, So obviously we can expect a sample from fourth sampler. It gives a beep sound when it is going to collect the sample, and we can also see the pump getting automatically switched on. So we can now expect a beep sound. Yes. So the pump is ready and it is sucking the sample. Yes, so the samples started coming, and the volume is also fixed, so obviously it is going to collect 10 ml. So the sampler will go back and it will back suck for cleansing. That is, it's cleaning the pipes with the buffer. Once the forward suction is finished, the sign is going to convert to positive, indicating now the sample is being collected in this direction. So it is going to change the direction in this way, and so this is going to change. So it is back pumping the excess solvent that is in the tubules, and the blinking of the light indicates it is still under the control of CPU. We can see the sampler coming up and the sign changes to positive, indicating the direction of flow is in here, and we can see the sampler coming up. So this is how a auto sampler Dissolution 2000 is going to successfully complete your dissolution process. So this will have very precise and accurate sampling method, accurate volumes. So this is going to give you very reproducible and accurate methodology where you can correlate your in vitro dissolution profiles with the in vivo drug release. Thank you.